Before going to the video, enable YouTube captions if you want. This will help you to understand more about what was mentioned in the video. We all know that the new Blender version 2.90 has been released. This version of Blender has been released with a bunch of features and tools. In this video, we are going to take a look at the new denoising tools introduced with this version of Blender, and we will learn more about this denoising stuffs. Let's open an old Blender project using the new Blender 2.90. This is a modern living room project designed with Blender 2.79, and this project was previously used on Blender 2.80. And this project previously used Blender Denoiser also. Now we are going to see what changes have been made for the denoiser in this version. Now we are in the Render Properties panel. You can see there is the new denoising stuffs managing section under the sampling. And you can see that render option is checked, and NML is selected from the drop-down menu. NLM, Cycles Native Non-Local Means Denoiser. This is the Blender inbuilt denoiser that was first introduced for the render denoising. This project had already used the previous version of Blender NLM denoiser. Blender 2.90 comes with two different new denoiser. So, don't worry about old denoiser settings and stuff. The new Blender sets things up for you. This is the denoisers settings panel. You can manage all the denoisers from here. Now let's see what the new denoisers are. We are going to talk first about the OpenImage denoiser. Intel Corporation has created this denoiser for the noisy image denoising. This denoiser takes some ray tracing information from the rendered image and denoise it so faster. And its workflow quite similar to the image filtering stuffs. And this denoiser is not new for the Blender. This denoiser was first released for the 2.81 version of the Blender, and its work on the composting part of the Blender. This denoiser uses CPU for the denoising, and it is faster than the Blender inbuilt NLM denoiser. It takes a small number of render samples and denoise it well. And this denoiser available for the rendering and viewport denoising. The second denoiser is the Optics denoiser. This denoiser is created by NVIDIA Corporation. And this denoiser is quite similar to the Intel OpenImage denoiser. And this denoiser also available for both part of the Blender rendering. For the viewport and the renderer. Let's see how Intel OpenImage denoiser works. We already talked roughly about Intel OpenImage denoiser. Now let's see how it works in Blender. You can select denoiser from here and activate it for any rendering. For renderer or viewport or both. First, let's look at how it works for the viewport. To do this, I will leave the denoise setting by default and go to the viewport and see how this works without the viewport denoise. Now you can see how noisy the scene is. Let's enable the denoiser and see how it works. You can see that viewport denoise has been selected to the automatic. If your computer has an NVIDIA GPU device, the Blender will automatically select the Optics denoiser. And it starts to denoise the scene. This PC works with an Intel i5 processor, and the computer doesn't have any NVIDIA GPU device. So, it automatically selects the OpenImage denoiser for the denoising. And you can see this render denoiser list doesn't show the Optics denoiser. If you have an NVIDIA GPU and it shows Optics denoiser, just select the OpenImage denoiser from it to work with OpenImage denoiser. After enabling viewport denoiser, you can see the viewport is denoising. And it has not yet reached the 32 samples, but the viewport is giving very smooth rendering. Let's see the denoiser configuring panel. As you all know, Previous versions of Blender had its denoiser configuring stuff in the view layers properties. The new Blender also has the same stuff there, but the difference is that the panels are different for each denoiser we choose for render. Now we are going to see how to denoise render using the OpenImage denoiser. Set the render samples to 32 and set the render denoise to OpenImage denoiser. And set render tile size to 32px. The tile size is already fixed to 32px in this project. For CPUs, 32px of the tile size is recommended. OK. Now render the scene. I want to let you know, use this lock interface feature to lock the interface while doing the render process. The lock interface reduces the render crashing, and it speeds up the rendering process a little bit. Now it's rendering the scene. After rendering the scene, you can see how much smooth this scene is. This is very similar to the final result of the previous project rendering. Let's see the results. It's best for this amount of the samples. OK. Let's render the same render setup with the NLM denoiser. It's rendering now. After rendering, you can see the denoiser mess with the scene. NLM denoiser can't denoise for this scene using this number of samples. In this scene, 32 samples with the OpenImage denoiser works fine, but the NLM denoiser does not work well for that number of samples. It doesn't mean that the NLM denoiser is not worked properly. NLM denoiser needs a possible number of samples, and the scene must be less noisy, according to this scene. In the last part of the video, we will compare both the denoiser with a possible number of samples and discuss about both denoisers. So, don't make any decision for the render denoiser selection. Now let's see how to speed up this OpenImage denoising. We earlier told that the OpenImage denoiser is not new for the Blender. An earlier version of the Blender had this denoiser for the compositor. The new Blender also has this denoiser for the compositor. Doing the denoising process using the compositor is more effective in different ways. Let's see how to set denoiser in the compositor. Always make sure that the render denoiser is disabled in the denoising section. If you did this compositor denoising without disabling the render denoising, the Blender would denoise the scene twice. First using the rendering process, after that it's denoise using the composition process. So, always make sure that render denoiser is disabled. Now let's set up the nodes. To do it, first we have to enable some render passes to get the render details that are needed for the denoiser. This is the OpenImage denoise node. Let's set the node setup. Connect the following connections. Noisy image to image of the denoise node. Denoising normal to normal of the denoise node. And denoising albedo to albedo of the denoise node. The noisy image output gives the rendered noisy image. And denoising normal gives the sharpest normal details of the current scene. Connecting this node keeps the object's normal details for the final output. Denoising albedo gives the main color details for the denoising. Denoiser can use this to keep the sharpest texture and color details. And those details will not be blurred by denoiser. Now set up the following node structure. Let's render the scene. You can see how noisy the rendering is. Now the rendering process is done. At the top header, it shows that the scene is composting. Now it's done. As you can see in the denoising workflow, it is similar to the render denoising we did earlier. You can see that the rendering time is shorter than the first time. This is also Intel OpenImage denoising, but this method is a bit faster than the regular render denoising. Blender renders the current scene first, after that it denoises the scene with the OpenImage denoising. It won't denoise every single tile after the path tracing. This methodology is quite faster than the first one, doing the rendering and denoising at the same time. We are now going to render this scene with the previously estimated rendering samples for NLM denoising. But this time let's render the same sample size using OpenImage denoiser. After rendering, let us take the render output and compare it with the result of NLM denoiser. Let's render this scene. For this scene, we are going to use default render OpenImage denoiser, not the earlier composition stuff. So, I'm going to clean up the denoising nodes in the compositor. Now we can render the scene. Rendering is done now. Now let's compare the render result. You can see some of the sharp details cut out by the OpenImage denoiser in some parts of the scene. and you can see some of the render tile marks are traced in the window glasses. Blender uses the OpenImage denoise after every single tile rendering for the render denoising. That's the reason for the tile marks tracing on the glasses. But we can avoid tile markings by using OpenImage denoiser in the compositor. And you can see that this area of the glass is shining for no reason. For this type of scene, we always recommend using the OpenImage denoiser through the compositor. Let's compare the both Blender denoisers. OpenImage denoiser works with high noise renderings. With a decent number of samples, we can get a better result of rendering. Sometimes with the correct number of samples, we can't keep all the render details. Available for a compositor. Works with progressive rendering. Available for viewport denoising. This is the main advantage of this denoiser. NLM denoiser works with less noisy renderings only. With a decent number of samples, always we can't expect a better result of rendering. With the correct number of samples, we can keep all the render details. This is the main advantage of this denoiser. Didn't available for a compositor. Didn't work with progressive rendering. Didn't available for viewport denoising. Now you can see more clearly the rendering output of both the denoisers and choose the right denoiser to suit your rendering. Based on these analyses and results, let's talk about what kind of denoiser is right for your rendering. If you need more samples for your rendering, and if you want exactly every detail of your scene, then the best choice for your rendering is the NLM denoiser. NLM denoiser works well for the details capturing. Always use the NLM denoiser for the photorealistic image rendering. Rendering takes some time, but the final render output is clearer than OpenImage denoising. If you want to quickly render a Blender animation, OpenImage denoiser is the best choice. OpenImage denoiser works so faster. You can see these render results. This is the image render with 32 samples. And this is in the 1500 samples. It's very similar to the final render results. So, you can use the OpenImage denoiser for your animations. I recommend using the OpenImage denoiser in the compositor. And this denoiser does not lose all render details. But the details capturing is less than the NLM denoiser. In the future updates on this OpenImage denoiser, we can expect more. The OptiX denoiser is quite similar to the OpenImage denoiser, and it also uses the same normal, color, and albedo to render denoising. OptiX denoiser also works with the viewport. So, if you have an NVIDIA GPU, then you can use the OptiX denoiser for the denoising process. Now we are in the project we worked on before, but the computer is a different one. Now, this project is on a laptop, and it has an NVIDIA GPU. Let's see, this PC has the OptiX denoiser for the denoising. Yes. You can see it has OptiX denoiser for the render. Now I am going to turn my Cycles render device to GPU compute, and you can see the selection won't work. First, we have to set the GPU compute setting in the Blender user preference. Let's do it now. I am going to use CUDA. The reason for choosing CUDA is that we can use CPU and GPU for the rendering process. So, I select the CUDA for the Cycles render device and save the preference. Now you can see that the GPU device selection process is working. Now I'm going to check viewport denoising for the OptiX denoiser. I enable the viewport denoising and leave it in the automatic selection. Blender always selects automatic denoiser as OptiX denoising for NVIDIA GPU users. And this time I set this start sample. This is the size to start denoising the viewport by the default it sets to 1. So, after the first sample viewport starts to denoise, it is not necessary to denoise all samples from the beginning. Therefore, set the middle size of the viewport samples to the denoise start sample size. It's a good and quick way to denoise viewport. When working with OptiX denoising for the first time, it takes a few minutes to begin the rendering process. After that, it starts to render. After 16 samples you can see it start to denoise the viewport. If we compare viewport denoising for both denoisers, OpenImage denoiser quite slow for the scene. Now we can do the render denoising using the OptiX denoiser. But the OptiX denoiser not available for the compositor. Rendering was done. You can see this denoiser also works with a small number of samples. But sometimes OptiX denoiser need more samples to denoise the scene. You know, we used a tile size of 32 pixels for this rendering. During GPU rendering, we need to set a larger tile size to increase render speed. For the GPU of this laptop, I set the rendering tile size to 128 pixels. You can also determine your tile size. In this video, we are not going to look at that part. But I can tell you that workflow very quickly. Try this technique to find your tile size. Get render results with 32 pixels, 64 pixels, 128 pixels, 256 pixels and 512 pixels on the same render setup, using the same sample size. Analyze the render time using the smallest sample size, such as 32, 64. After that, see what tile size will complete the rendering in less time. That tile size is the optimal tile size for your computer. You can see the difference in render time when the tile size changes. Let's talk about these data passes available for these denoisers. In the View Layers properties, we can see these render passes available for these denoisers. The options available are the same, but each denoiser takes different options for default selection. Why is this happening? OpenImage denoiser works with this render passes without any problems. We always recommend using this color, normal and albedo render passes with OpenImage denoiser. You can also change these render passes to suit your render needs. But the OptiX denoiser only works well for albedo and color passes. Sometimes it leaves some artifacts for the usage of normal passes. And it works well without the normal render pass. So, we always recommend using OptiX denoiser with color and albedo passes only. And sometimes these passes depend on your project for both denoisers. Then change the render passes and see which one is good for your rendering. Feel free to change these passes for your renderings. These denoising passes are given for that reason. I hope you have learned something new from this video. If you like this video, hit the like button. If you want to watch more videos like this, subscribe to our channel, click on the bell icon on the side and select all. This will allow you to receive notifications for future uploads. If this video helps your Blender work in any way, don't forget to comment on how. If you have any other issues with this video, please comment as well. And if you would like to support us, please share this video with the Blender users you know. Learn with IBN.